topic is linear dependence and independence. So let's do this example. Determine whether the set of functions x plus 3, x squared minus 5 is linearly dependent. So the definition is right here. f1 of x to fn of x is linearly dependent if it exists. This is just simple for there exists c1 all the way to cn, not all 0. This means not all 0, such that c1 f of x plus all the way to cn fn of x is equal 0. And independent means if the linear combination is 0, then all the constants or the coefficients of the functions have to be 0 for every x in I. So let's do this example. So first, we write the linear combination and we set it equal to 0. So c1 f1 of x plus c2 f2 of x plus c3 f3 of x is equal to 0. Remember, this is f1 of x, f2 of x, and then f3 of x. So c1 times our first function, which is x plus 3, plus c2 times second function x squared, plus c3 times third function, which is x squared minus 5. We set this equal to 0. And then we see if we can find all, at least, we can find c1, c2, c3, at least one of them is not 0. Alright. So what do we do? Just like previous example, we distribute. If you distribute, you get c1x plus 3c1 plus c2x squared plus c3x squared minus 5c3, and this is 0. And just like the previous example, you factor x squared first. So these are the terms that have x squared. So that would be c2 plus c3 factor of x squared, and then factor the terms with x. There's only one anyway, c1x, so plus c1x, and then whatever is left, 3c1 minus 5c3, so 3c1 minus 5c3, and that's equal to 0. But remember, 0 is the same thing as 0x squared plus 0x plus 0. So therefore, the coefficient, these are two quadratic functions. They equal if their coefficients are the same by definition. So this 0 has to be equal c1, and this 0 has to be equal this. So c2 plus c3 has to be 0, c1 has to be 0, and then 3c1 minus 5c3 has to be 0. Now, this tells us c1, we already know that c1 is 0 automatically. Now let's see if we can find, since c1 is 0, looking at this one, plug this, no, not that one, plug a c1 0 here, it tells us what? This means 3 times 0 minus 5, c3 is 0, which means minus 5 c3 is 0, because 3 times 0 is 0. So c3 is equal to 0 divided by negative 5, which is 0. Now we found c1 0, c3 0. Since c3 is 0, if you plug it here, you get c2 plus 0, which is 0, which means c2 is 0. So the only constant that we can multiply, we can write a linear combination of these functions, f1, f2, or f3, that will give us a 0 are zeros. So now we can tell c1 is equal c2 is equal c3 is equal 0. Therefore, using second definition, therefore for every x, by the way, in the interval I mean here for all real numbers, the will be just all real numbers. So this will be, the set is independent, or linearly independent, of course. Alright, that's it for this example.